Hi students, how are you? I hope you all are fine and safe. Stay home, stay safe and take prevention for this COVID-19. I am doing the same thing what you are doing. So today come to the next chapter, that is chapter number it is chapter number 3, that is called as the elements of the geometry. The elements of geometry. What does this mean? Elements means what are the things involved in geometry. So what is geometry? As you know, all of you, geometry means the study of the earth and its measurement. Geo. What is geo? Geo means earth. And what is metry? Metry is derived from a Greek letter that is called metron. That is called measurement. So the earth measurements in various ways, we are saying that as the geometry. So what are the elements involved in this geometry? Today I will go for the introduction part to you all. So let's see what is the introductory part. Introduction, I wrote something for you and I will explain that after you read, I will explain that. See now, we have seen large structures like bridges, dams, school buildings, hostels, hospitals, etc. The constructions of these structures is a big tax for engineers. So what I wrote, we have seen large structures like bridges. You already saw the bridges, the joining two rivers, big bridges. The dams where the water is going to be stored, reservoirs that are called dams. And the school buildings, big school buildings like our school building we have, like that the school buildings and the hostels where you are staying for reading purpose, or some army personnel are also staying, those called hostels. And hospitals where the patients are going to be treated. And these constructions, what is saying? These constructions, structures, these are some structures which we are going to construct, is a big tax for the engineers. The engineers are there. Like this, we are not going to build anything up. There are a lot of engineering ideas behind it. And in all engineering ideas, there are some elements of geometry is coming for act. So I hope you understood this line. So what I said, generally the elements of geometry is applicable to these type of big structures in our life we are observing, that is the bridges, the dams, school buildings, hostels, hospitals. So it is a big tax for the engineers to build that. So what are these structures include? What is inside these structures? Right now these lines will tell you. The size and shape of a structure. The size and shape of a structure include the foundation. Foundation means from the bottom part. From the bottom you have to construct it. If the bottom will be constructed nicely, then the top part will resist on that. So that is called as the foundation. When you are going to build a house, definitely we are going to go for a nice foundation for it. Nice foundation includes the plinth area, in how much area you are going to build your house, the plinth area, the size of the walls, what should be the size of the walls in your home room or in your home. You observe the side of your walls. It may be 8 feet or 10 feet high. After that a roof will come. That is written. Size of the walls. The elevations mean the staircase on which we are climbing towards the top. That is called the elevation. Elevations are the staircase. And the roofs, etc. After that, it will be said as a room. It is said as although the construction is over. And after that, you will go for interior decorations. But for the main observation is that we have, when we are going for a construction, the engineers are taking these things into account very carefully and seriously. What are those? The foundation, the plinth area, the size of the walls, and the elevation, the staircase, and the roofs. After that, the interior things will be constructed. But these things are not constructed properly and the engineers are not serious about it, then the building is going to collapse and it will fall down. So here in these all parts, the foundation, the plinth area, the size of the wall, the elevation, these all things is a big tax for the engineers. And here we are applying the elements of geometry, the things inside the geometry. So the measurements must be accurate. So we are taking the geometry very seriously when you are constructing this type of things. I hope you understood it. Now you see what he said, the great constructions. But right now some modern technologies are available. The engineers are with very modern technologies now. So the excavators are there, the manpower is there, and also they have skilled with very good equipments, and modern technologies are there, advanced technologies are there with them to dig the soil. But in ancient time, you just think about ancient time. In ancient time, earlier time, they already constructed this type of wonders in the world by applying the elements of geometry. By this application of elements of geometry, that time engineers also, they did a nice job. And those are right now considered as the wonder of the world also. Example, the great constructions. What are the great constructions? The pyramids in Egypt, it is underlined red. The Great Wall of China, the Great Wall, the temples, the old temples, ancient temples, the mosque, and the Taj Mahal in India, Charminar in India, Eiffel Tower in France are some of the best examples of this geometry. Some best example of geometry. That means here the geometry is applied, the elements of geometry is applied by the engineers very seriously. And right now we are going to observe those things. They are not going to collapse after several years also. So this type of things leading to the application of geometry in our constructions. So I hope you understood this introduction part. So what is that introduction part today? The elements of geometry. Why geometry we are going to apply? What is the things inside the geometry which is making geometry so useful? That is when you are building such type of bridges, dams, school buildings, hostels, hospitals, these constructions, and behind them there is a big tax for the engineers, because here the application of geometry is very seriously going to be used. And the size and shape of the structure. What should be the size and shape of the structure? How should be a room constructed? How the plinth area will be? How the foundation will be? How the plinth area? What is the size of the walls you are going to put? What is the thickness of the roof? How it will be built? And the elevation, the staircases. To understand these geometric principles involved in those constructions. So these are having all geometrical geometrical measurements or principles inside them. So to understand them, we have to know the basic elements of geometry. The basic things of geometry we have to know, and the engineers must apply it very seriously and cautiously. Otherwise, the building is going to, the construction will collapse. Then I already gave you some important examples of the engineering constructions in ancient time. That is the pyramids of Egypt, the Great Wall of China, the temples, the mosque, the Taj Mahal, Charminar, it is in India, and Eiffel Tower in France are also some of the big engineering constructions of that time. And in these all constructions, behind all of these constructions, the thing is that which is applied, that is called the elements of geometry. I hope you understood it. Now come for the next part. What is the next part? The next part is the history behind the elements of geometry. What is the history behind this element of geometry? Let's go for it. I wrote something. See, the domains of mathematics will study the main cause of mathematics to study the shapes and size of the structures. Mathematics wants to know the shape and the size of the structure. What is the structure? What should be the shape? What is the size of it? And these all can be described under the geometry. So the branch that is called geometry, under that branch we are going to discuss about the shape and size of the object or solids. Understood now? Now come to the point. I wrote the word geometry is derived from the Greek word geo. What is that? Geo. That means you break geometry, it will give you geo and it will give you metry. So geo means the earth. I underlined it. So geo means the earth, and the metron, the what is called metron. The metron is called the measurement. Metrons are called as the measurement. So it is in Greek, it is the geometron. That means metron right now is pronounced as metri. So geometry. Geometry means the measurement of the earth. The measurement of the earth in definitely going by three ways, that is called as lengthwise, and another is mass-wise, and another is called as the time-wise. But here we are concerned about this lengthwise, length and breadth-wise measurements in geometry. I hope you understood this line. Now come some mathematicians in our ancient time, they already applied this geometry, and they know and they say about the elements involved in this geometry. One of them is, first one, the Bodhayan. Bodhayan is an Indian mathematician who said in 18th century BC, before Christ, 8th century BC, before Christ, he composed the Sulaba Sutra. What is this called? Sulaba Sutra. Sutra means formula. Sulaba means examples, models of some formula. Sutra means formula. Sutra in Hindi, it is a Hindi word. It is called as formulas. So formulae. So Sulaba Sutra, that means some model formulae he already gave in 8th century before Christ. Before Christ, 8th century, he already said about the elements of the geometry. Who is that? That is the Bodhayan. The Bodhayan, right now, the Bodhayan, and that contemporary was, after that, the Pythagoras. Pythagoras, best known as the Pythagorean triplet. Pythagoras is known as Pythagorean triplet. Pythagoras applied his formula on a right angle triangle to know the largest side of the triangle. What is the largest side? The largest side is called as the hypotenuse. So the hypotenuse he called as the H, or the largest side, and the perpendicular will be there because it is a right angle triangle. I said you it is a right angle triangle. So this is called as the hypotenuse. This is the perpendicular and base. He gave the what? He known as for his Pythagorean triplet. Triplet means he gave this, if these three, these three sides, 3, 4, 5 will be a triplet. That means if one side is 3, the another side is 4, then he is able to say the largest side by applying his theorem. What is the theorem? I am writing here a little bit for your knowledge. That is largest side square, the h square, is equal to the perpendicular square plus the base square. This is called as the Pythagorean theorem. According to that, he gave the Pythagorean triplet. He already discovered some triplets, and that is 3, 4, 5 and 5, 12, 13. So these triplets of Pythagorean theorem of these triplets was matching to the Bodhayan Sulaba Sutra. That is matching to Bodhayan Sulaba Sutra. Sulaba means the model, and the Sutra means the formulas, the model formulas of that time, 8th century BC, by Bodhayan was matching to Pythagorean triplet. That means Pythagoras gave the triplets for the right angle triangle, that 3, 4, 5 and 5, 12, 13. It is matching to that. So these are the genius mathematicians on that time, ancient time, who already said about the elements of geometry. What is the geometry behind? Suppose we are sitting here and we are looking to a mountain, and when you are looking to a mountain, the mountain top to my eye, and if I will drop a perpendicular from the top of the mountain to the ground, that will be my perpendicular, and from there to me, that is the base, and I can able to say the largest side by calculating this triplet. That means if I will imagine myself, if I am here, if I am sitting here and looking to this top, and I guess this one, then I can easily say the distance between the mountain top to my eye by putting this Pythagorean triplet or Bodhayan Sulaba Sutra. So these are the genius mathematicians on that time who said us about these elements of geometry, and we are right now helpful for their inventions. Now come to the point, another one. Now what I am saying, the chapter is concentrating on that. That means it is focusing on this mathematician. This mathematician is called as the father of geometry. Who is the father of geometry? That is the Euclid. Who is that? That is called as Euclid. So the father of the geometry, Euclid. So another ancient mathematician came And after that, the former father of the geometry, that is Euclid, he's created first system of thought. He's thought something, and he gave his thought based on what we are calling as today's 3D figure, 2D figure, 1D figure, no dimension. He already thought on that time about this type of dimensions. We are saying 3 dimension, 2 dimension, 1 dimension, and there is no dimension. He already thought on that time and gave us his thoughts of his elements of geometry. What is that? Look at it. The beat one, he took a solid that is looking like a what? Like it is a cuboid. It is a cuboid. It has a length. This is the length. It has a length. See, this is the length. So this is the breadth. And what is this? This is the height. So due to this L, B and H, 3 dimensions, it is called as a 3D figure, and it is a solid. Clear now? Understood? Now my duster is called as the 3D. Okay? But when I am looking about this one, see, only this one, what I am observing? I am observing a face, that is a surface. This is a surface, this is a surface, this is a surface, this is a surface, top one is a surface and bottom one is a surface. So I am observing 6 surfaces, and surrounding it I am observing 4 surfaces. Clear? So now as the one surface I took it here, that is my beat 2, and it is a 2D figure. Why? Because it is having only length and breadth. So see now, it is existing in 2 dimension only. For that reason it is called as a 2D figure. This is existing in 3 dimensions only, so it is called as a 3D figure. So from this, if I am taking only one, then what is this called as? This is called as a 1D figure, because it has only length. If I am taking the length out here, then it is called as a 1D figure, because it has only 1 dimension. So this can be compared to a straight line. These are straight lines. So a 3D surface can be converted to a 2D surface, can be converted to a 1D surface. Then there should not be any dimension, because a straight line, you know, it is consisting of a lot of points. A straight line is a set of points. So when you will join the points, you will get a straight line. Clear? So there are a lot of points in on the straight line. So what we got at last? We got a point which has no dimension. That means no length, no breadth and no height. In 3D picture, 3 dimensions, one is the length, breadth and height. When it will be one surface only, that is a 2D picture, that is having only length and breadth. Then if I take a length here, that is having 1 dimension, and it is called as a straight line. And after that, I will just go to represent, that is called having no dimension at all. That means no length, no breadth and no height, and it is always called as a point. So a point, if they are in the straight line, there are a billion of points, and so billion of set of points is giving you a straight line. Now what I said, he is the father of the geometry, who thought these things on that time and gave us all the clues towards the elements of geometry. For that reason, he is called as the father of geometry. The next, I am going. Now you see what I want to say you. Now you see what I said to you. After that, the father of the geometry, Euclid, what he did, he created the first system of thought based on. He thought about a plane surface. What he said about a plane surface? A plane surface is a 3D solid figure. A 3D means 3-dimensional solid figure, in which the length and breadth and height are there. Then when you took one surface from that, it is giving you a 2D picture. So it is a length and breadth. Then what he did, he go for this one line. He just took it, the length, 1 dimension, he took it and he said it as the 1D picture, that is called line. Then the line, he showed us the points have no dimension at all. So a 3 dimension converted to a 2 dimension, converted to a 1 dimension, and also having no dimension. That means no part in it. So according to that, what he wrote, he based on the observation of the Euclid. What Euclid observed in this, he one by one he gave the elements of geometry, defined the element of geometry called as what he gave to the element of geometry. He gave the first thing that is called as a point. Okay, understood now? So what is a point? Now what is a point? A point which has no part. Means it has no part, no dimension at all. So it is dimensionless. A point is dimensionless. Then what he said? He said about a line. What is a line? A line is a breadthless length. That means a line which has only length. He took a length here, which has no breadth. So it is a one-dimension figure. It has no dimension at all. The point, it has no dimension at all. And the line, it has one dimension. That means only the length. No breadth is there. So it is a breadthless length according to Euclid. Understood? Now he come to the straight line. What is a straight line? A straight line, he said it as a one dimension. That means in a surface there are two dimensions. If you took one dimension to here, then it is a one dimension figure and called as a line. Line constructed by the set of points. So no part is giving you one part now. That is called as the line. Now come to the straight line. A straight line which lies evenly with the points. The straight line is lying evenly. I underlined it, straight line which lies evenly with the points. That means a straight line, it is having a lot of points in it. So it is evenly lying on the points. It is evenly lying on the points. Understood now? Now it is a 1D figure. Now come to the surface. Look at it. This straight line is converting to a surface. Surface that which has length and breadth only. That means it has only a length and a breadth. That means this is those two lines. When they are meeting, this is a line, a length, and this is the line breadth. When they are meeting, they are forming a surface. That means a surface has two dimensions only. That is the length and the breadth. Okay, in rectangle or in the square it is side. So this is the basic idea of the thought of basic ideas from Euclid, and he defined these things like this on that time. Clear? Now you come to the surface. The surface, the edges of the surface are straight lines. That means the straight line edges are meeting another line. So I am creating a surface here. That is a two-dimensional figure. And this two-dimensional figure is again giving you a plane surface. Surface and a plane surface. See, I wrote here a plane surface. So what is a plane surface? A plane surface having three dimensions. That is the length, the breadth, and the height. This is the height, this is the length, and this is the breadth. When these three dimensions are there, they are giving you a surface. So surface, right now, these are called as the plane surface. The difference between, according to Euclid, the difference between a plane surface and a surface is, the surface is giving you always a two-dimensional figure, and the plane surfaces which are giving you a three-dimensional figure, and the lines are giving you a one-dimensional figure, and the points are giving you no dimensions at all, no length, breadth, height. Okay, so no dimensions at all. So it is already given by Euclid on that time. For that reason, he was known as the father of the geometry, and he just defined, or he just discovered the basic elements of the geometry. What are the basic elements according to Euclid? The point, the line, the straight line, and the surface, and a plane surface. Still now, we are working on those type of geometrical elements of geometry to solve our basic geometrical needs. For that reason, he is called as the father of the geometry. Now I want to say you, see, some red lines are given to you. The red lines is giving you the, that means I point it for the important parts, and these are all called as the definitions according to Euclid's geometry. Euclid's geometry or elements of geometry, these are the definitions according to Euclid. You have to remember it nicely. So I put a notice board here. The notice board is saying remember or learn it well, because these are the, in this chapter, this type of things will come. So some theoretical ideas are there. We have to understand it, and we have to practice or by head it nicely. The definitions we cannot write from our own mind. We have to follow what the Euclid said for us. So these are the basic geometrical elements of geometrical definitions given by Euclid. And next, now you see, we are coming to the next page of this elements of geometry. What is that? That is, Euclid used his definitions. Just right now I said you about those definitions, points, line, straight line, then surface and plane surface. Among those definitions, he used these definitions in assuming some geometric properties. He starts to think about some geometrical properties, and in that geometrical properties, he divided them into two parts. What they divide? He divided it into two parts. He assumed some properties by taking his definitions. After taking his definitions, he divided that into two parts. What are the two parts? The geometric two parts are the axioms and the postulates. He divided them into that properties. He divided into two parts. One is called as axiom, another is called as the postulates. So these are very new words for you now. Let's discuss about this. What is an axiom, and what is a postulate? An axiom. What is an axiom? An axiom in geometry, oftenly you will see in your textbook the axioms. What is that axiom mean? That axiom means that axioms are the statements. These are some statements which have self-evident fact. That means it need not require any proof. That means they are some statements which have some facts behind them. That means it was already proved and it is accepted by all, and it need not require any proof further. It need not require any proof further. So these properties, among these properties, the axiom part are those statements which already having some evidence in its back. So evidence fact in its back. So it need not require any proof. Again, to prove we need not require anything. That is final. So that will be accepted by all. Then example is, see, sum of the angles of a triangle is 180 degree. Yes, we know that, and after that it is coming under a theorem. That sum of the triangles prove that sum of the, it is already a proof. How the proof is, you are proving. So it is a proven statement. That means it is already proved. And why it is said as a proven statement? Because some evidentiary fact, evidence are behind them. It is already having some evidence in it. So it is called as a axiom which need not require any proof. I hope you understood. So what Euclid did, he took his definitions and assumed and think something on which he already proved something, and some parts still in assumptions. That means it is carry on. It is going on to be proved. So those things are under the next heading, which are already proved. That is called under the axiom heading. That means it need not require any proof. Now come to the postulate. Postulates are used for the assumptions made in the geometry. Assumptions means you are assuming something. We have to prove it again. That is called as the postulates. That means it still needs some evident fact behind it. It needs evident fact behind it. Still some more evidence is required for that. For that reason, it was not accepted by all. It is under the assumption. For that reason, it is under the heading of postulates. So postulates are used for the assumptions made in geometry. Example, a terminated line can be produced infinitely. Yes, we can. When we are saying a terminated line, what is a terminated line? A line which is having some, suppose I am saying line is terminated, I am taking a length of a line, and again I want to produce it infinitely. Can I produce? Then it is an assumption. Can I produce it? Then I have to, if I will produce, if it is yes, then I have to give some evidentiary fact behind it. That is under the postulates. So I hope you understood what is called by axiom and what is called by postulates. Like that, there are many axioms. Right now it is given in your textbook. For Euclid gives some axioms for you and also some postulates for you. You have to remember them, and also I will explain what is that axioms and postulates meant about. I hope this part is very clear for you. So finally I am saying the definitions of the Euclid is still further under some assumption of Euclid, and these assumptions he was giving some properties to you. Those properties are divided into two parts. One is called axiom, another is called postulate. Axiom part, he already gave a lot of evidence fact behind it, so it need not require any proof. We are going to accept them blindly. Next to postulates, we are still going on working on them, and definitely day will come, and so a lot of evidence we are going to say that as an axiom. But still it is under assumption. So example, terminated line can be produced infinitely. Yes, we have to give some evidence behind it that it should be produced infinitely. Then for the axiom, it is already proved. See, sum of the triangles of a triangle is 190 degree. It is already a proven statement. I hope you understood it. Now I want to show you some axioms of the Euclid's. The evidence gave by Euclid's, that is called axioms of the Euclid axioms. I am going to discuss it now. According to Euclid's, come to the Euclid's axioms. So there are 7 axioms given by Euclid. I wrote it here, and one by one I am explaining you now. See, things which are equal to the same thing are equal to one another. Suppose one cuboid is there and another cuboid is there of both dimensions same, LBH, length, breadth, height, all are same in the two. Then the two equal cuboids, they are same to each other, are equal to one another. That means one is equal to the another. Understood? Similarly, take a circle of radius 4 cm, then another circle of radius 4 cm. So both are equal to each other. So they are equal to one another. They are equal to one another. This is the one axiom number 1. Things which are equal to the same thing are equal to one another. Next, if equals are added to equals are added to equal. One is added to the other. The whole is also will be equal. The whole will be equal according to the measurement of the first and the second. The whole will be equal to the both. Clear? Now, if equals are subtract from equal, if they are subtracted from equal also, the remainder which is remaining are also equal to the one part, to the single part. Next, things which coincides with one another, both are coinciding with one another, then they are equal to one another. If one line is coinciding with the other line, then one line can be seen because both are equal to one another. So now the whole is greater than a part. The whole means the total is greater than a part. Suppose one apple is there, we are cutting it into 4 parts. So the part is 1/4 of one apple. So one apple is definitely greater than 1/4 of the apple. The thing is that the whole is greater than a part. Next is things which are double the same thing. So one thing is double the other. Then the same thing are equal to one another. So if you divide them, they will be equal to one another. The double thing, if you divide them, then 2 will come, then the 2 will be equal to one another. Next, things which are half the same thing are equal to one another. Suppose one thing is there, you are making it half, exactly half, then the 2 parts will be equal to one another, he is saying. If you are making double a thing, then the 2 parts will be equal. If you make half a thing, then from the whole, then the 2 parts will be equal. Then the whole part is definitely greater than a part. The whole is greater than the part. Which are things that are coincides with one another, they both will be equal to one another. And if equal are subtracted from equal is subtracted from, the remainder is equal. Then if equals are added to equal, then the whole, which is what is coming, that whole will be equal to the both. Then things which are equal to the same thing, one thing is equal to the same thing, then they are definitely equal to one another. They are resembling one another. So these are the Euclid's axioms. You have to remember, very, very important. You have to learn it well, and definitely you please learn it well, and just you have to by head these things and practice these things in your practice notes. So these are the Euclid's axioms according to Euclid. The next is the Euclid's postulates. I will do postulates with some examples. Now, Euclid's postulates. The Euclid's postulates. Now you see what are the Euclid's postulates are given to you. Look at this, what he said. There is a unique line passes through 2 given distinct points. So there is a unique line passes through 2 given points. So there are 2 given points here, A and B, and in between A and B, one line is passes through. There is one line pass through to giving distinct points. The first postulate. Second postulate, a line segment can be extended either side to form a straight line, or it can be said like this: a terminated line can be produced infinitely. Among these two, which one you like, you say. A terminated line can be produced infinitely. Terminated means what? That means a line already given. That means it is a PQ line. It has some measurements here. But what he said, a line segment. It is a line segment of some certain measurement. Now it can be extended either side. It can be extended on this side. It can be extended on this side to make a line also. Clear? So this is a terminated line can be produced infinitely. So this is the second postulate of Euclid. Third postulate is a circle can be described with any center and any radius. If you take any center and any radius, look at it. First center I took and the radius I took 3 cm. A circle came, and I draw a 4 cm radius circle. I draw a 5 cm circle radius. So in any radius and any center, we can draw circles. Next is right angles are equal to one another. Look at it. One right angle is like this, another right angle is like this, another right angle is like this. But the measurement is still 90 degree. So all right angles are equal to one another. Now the axiom number 5 is the if a straight line falling on the two straight line. If a straight line falling on two straight lines, one straight line is falling on two straight lines. Suppose one straight line is this one, L. I am let it be L. So L line is falling on AB and CD. So if a straight line falling on two straight lines, now L is falling on AB and CD. So a straight line will falling on two straight lines makes the interior angles on the same side. Same side. Make interior angle means 1 and 2 are called as the interior angles. Interior angle on the same side. Same side of it taken together is less than two right angles. If you add these two, and it will give you less than 180 degree. Try to remember, less than 180 degree. If you will add 1 and 2, and if it will be less than 180 degree, less than 180 degree, that is 1 plus 2, angle 1 plus angle 2, less than 2 right angles, then the two straight line produced infinitely meet at that side. Definitely, when you will produce these two straight lines, definitely they will come to meet one another at an infinite point. If it is less than 180 degree, then you will ask me, sir, if it is equal to 180 degree, then these two lines will never meet one another. Then two straight lines will never meet one another. If it is 1 plus 2 is equal to 180 degree, then these two straight lines will never meet one another. They are parallel to each other. But if it is less than 180 degree, they are going to meet at infinite distance. At infinite distance, they will go to meet at infinite distance. Understood? So this is the postulate number 5. Okay. Now come to the concluding part of the elements of geometry. So what is the concluding part? Concluding part is another thing I am going to show you. A definition of conjecture. Definition of conjecture. What is that? Conjecture. Conjecture, but definition is statements which are neither proved nor disproved. Neither proved nor disproved are called as the conjecture, or sometimes it is called as the hypothesis. Sometimes it is called as the hypothesis. So conjecture sometimes called as hypothesis also. So the statements, some statement is taken, it is neither proved nor disproved. We are called as, in that stage it is, that is called as the conjecture or hypothesis. Example, see, every even number greater than 4, every even number can be written as sum of 2 primes. Can be written as sum of 2 primes. Greater than 4, let it be, after the greater than 4, it will be, let it be 5. Can 5 be written as 2 plus 3? It is that one. So it is not disproved, neither proved. Nobody proved this, or it is not in the disproved condition also. In that condition, if it is there, then it is called as a conjecture or hypothesis. Very interesting. So a thing which is not proved and neither disproved also. So Even number greater than 4 can be written as the sum of 2 primes. Sum of 5. So after greater than 4 it is 5. So can I write 5 2 plus 3? It is yes, but again it has no proof at all. So this type of conditions are called as hypothesis. Clear? So conjecture, it is clear to you. Now come to the theorem. Theorem is also a conjecture. Theorems are also a conjecture, and a hypothesis is proved to be true when it is proved to be true. That means this hypothesis is not proved, so it is under conjecture. But which hypothesis is already proved, that means it is taking the approval of proof, then it is called as a theorem. Then it is called as a theorem. This is a theorem. Clear? So a theorem, what is a theorem? A theorem is proved by a logical steps. So a theorem is a hypothesis or a conjecture which is proved by some steps, logical steps. That is called as theorem. But theorem is a conjecture. Conjecture, but which type of conjecture? The conjecture which is already proved by some logical step. That is called as a theorem. Now, like this conjecture and theorem, I hope you understood it. Like that, you imagine Euclid deducted as many as 465 propositions. It already gone up to 465 propositions. Some propositions means statements come to Euclid, and he started to prove it by in a logical chain using its axiom, postulates and theorems. And already some theorems are already been proved by Euclid also. 465 propositions. You imagine, for that reason Euclid is called as the father of the elements of geometry, or some books giving the top heading as Euclid's geometry. In your book it is the elements of geometry. I hope you understood all the things it is there in the elements of geometry nicely. And please practice it. Go for your running notes and practice it nightly. Read the textbook thoroughly, one by one step by which, and practice it, by which it will be very clear for you. Thank you very much. Bye.